Okay, so we're looking at chapter 10, developing the construction sequence, Cook and Williams. Why I've put chapter 10 in here is basically it assists you. You can think to yourself, you can't really put in a competitive tender if you haven't been on a project, because you won't have an idea of how long should a project be. If you go to site, you don't have the necessary experience to really understand what risks of a site might be. Or how long it should really take you to construct a six-story building. You can have the best programs, you can have the best resources or tools to actually present to your client that yes, we can do this within 12 months. But if you don't have the experience of your labor and what the labor outputs are, then yeah, it's just empty promises that you're actually making on your program. So this is your developing your construction sequence, just also a bit of a theoretical look at how it's done. So your construction sequence is this certain thought process that we go through, the program considerations is used, and the resource considerations as well. Then continuity of work. This is, for instance, I always use this example for FaceBrick, for instance. Whenever you're doing your sequencing, you have a team of FaceBrick layers, and your team of FaceBrick layers will not necessarily be. You have to use your FaceBrick layers to finish one whole facade, and then you can use another FaceBrick laying team on another facade, because each FaceBrick layer has a signature on his when he puts down his bricks. There's a certain way that he picks up the brick, how he puts on the mortar, and how he places his brick that actually shines through when you look at a facade. You can immediately see if it's someone else who puts a little bit more or puts down the brick harder on the one side and then rolls it on the one that puts it down on the other side. The signature you can actually see. So whenever you're doing signature or your sequencing, that's the type of things that you need to look at. So that type of thinking and that consideration needs to be part of how you think when you're doing your sequencing. Okay, and then this is very important. This is actually what the guys actually wrote on. It's sequencing on construction operations is you have to think. It's almost like common sense. You remember in that second lecture that we had, common sense isn't for everyone, or isn't the same for everyone, but with experience, common sense actually becomes more reality. So whenever you're sequencing construction operations, you first have to sequence your operations. So you list all the items that you're going to do. You base it on your drawings, identify activities, and you think about how it's done. You prepare your phasing diagram, and then you look for significant elements for the stages in the construction. Do not have too many activities. That's something that the guys usually makes a mistake with. You go into so much detail when you're doing your sequencing that you kind of lose the plot. You forget to step back and look at the holistic picture. I've seen that many times on projects where you're so focused on the details that you kind of lose sight of what the whole picture should be. Okay, then do not worry about minor detail at this stage. So when you're sequencing it, look at your basic items. But then your construction method, choice of plant quantities then follows. So you have your sequencing. Okay, we need to do the trenches, for instance. But now you can think about, okay, are we going to do it with TLBs or are we going to do it with labor? That type of thinking is they have craneage, material handling, hoisting, scaffolding, temporary works, etc. Then you have your program durations. Why you think about your method is it will influence your sequence. So you've got your sequence done, and then you've got your program or your durations. So if everything goes well in the winter school, we'll do a bit of Microsoft projects, and we're actually going to do one project with you guys, and we're going to sequence everything, and we're going to then build up the your time on it, and then we're going to start linking it. So you first build your items, you sequence it, then you put in a time or duration to it, and then only you start linking the items with each other. Okay, resource availability of subcontractors, plant, labor, supervision, etc. Then you program out on the bar chart. Okay, that's the final step. So this is only the final step when you're doing your sequencing, is your bar chart or the visualization of that. Okay, then we've got the example here. I think you guys can go through it as simply, but it basically the sequence of work that they started with is to excavate, blind base, and then the floor construction, wall construction, backfill earth. The sequence is also dependent on the basement size and the operation size and so on. Okay, then they just example of illustration how this thought process can be developed into a practical program. So you have your sequence, your key considerations, main program activities, and then you have your linked bar chart. So it's that diagram that we've done, but just put into practice. Okay, on figure 10.2 shows the cross section through in situ concrete basement. Your key considerations is the sequence of the work requires consideration of the ground conditions, as this directly influences the earth support methods and which is adopted on site. This might include the use of sheet piling, battered excavations, etc. Then looking at the program activities, we've got all the items that's been listed there. So you've got your excavations, concrete blinding, floor construction, wall construction, and then your basement. And then you put in your time to that, and then you can build your program on that, your bar chart. And this is the bar chart that they've basically done. So it's a very nice example of how you can build up your bar chart easily. And that's it. Any questions? I think it's very straightforward. You guys will see it's theory basically. Hopefully when we finish with all the units, we'll get our teeth into the actual practical side of it. But if you know the theory, it's quite easy to actually do the practical side of it, because you just apply your steps as you're going along.